I work at a web agency called Sparkbox, and I was working with a client. And this client, they said, we have a web animation, and it looks something kind of like this. All right? There's a lot of motion, a lot of activity, a lot of color, and there's like these devices that are getting bigger and larger and content shifting around. It was really impressive. They said, we want to put this animation on our website, and we already have it coded up. We just need you to just drop it right there on the website. So I said, sure, I can do that. They sent me a zip file over email. I opened the zip file. I started looking at the code, and the code looked something like this. This is HTML, even though it doesn't look like it. In fact, if I were to highlight all the inline styles, that's what it would look like. So I went back to them and said, well, what's the big idea? Where did this code come from? And they said, okay, we actually generated it with a tool called Adobe Edge Animate. And this is a prototyping tool, and it's not even actively developed anymore. And that's where it came from. So I said, you know what, I don't feel comfortable putting this on a production website. If anything goes wrong, if there's a cross-browser issue, it's not going to be maintainable. We're not going to be able to debug it. So they said, okay, that's fine. We trust your judgment. How about, would you like to take a crack at putting this animation together for us? And I said, I'll get back to you on that. It turns out I've messed around a little bit with web animation, but trying to build something as complex as this thing they had in mind was something I'd never done before and something I didn't know how to do. So I turned to Google and I started trying to do some research on web animation. And I wanted to know what all the different techniques and approaches were so that I could compare them and kind of build a mental model of how I could build something like this. And what I wanted was, I was thinking in my mind of a project that's called To Do MVC. And maybe you've heard of To Do MVC. It's a way to compare MVC JavaScript frameworks. And the way they do it is they take a project, like a to-do application, and they build the same thing using all sorts of different MVC frameworks. And that serves as a reference point for you to compare these frameworks to each other. And I thought, I really wish there was something like this for web animations. And since I couldn't find anything like that, I started, putting something like that together myself. It was to help me understand all the different web animation approaches, but also to kind of demonstrate those things to other people as well. I ended up calling it Bouncy Ball, and you can find this online. It's on GitHub, on the Sparkbox GitHub repo. And the way it works is pretty simple. There's a bunch of web animation approaches across the top, and you can just click through each of those approaches and see the source code on one side and see the bouncing ball that is animated by that code on the other side. And then you can learn more about each of these approaches. In the process of putting this together, I learned a lot about a lot of different techniques. So the 14 ways to bounce a ball that I want to talk about are these right here. And what I want to do is I want to just kind of give you a brief overview of these approaches, and then we're going to kind of dive a little bit deeper into some of the things that transcend all of these approaches and what we can learn about animation in general. Now, there's more ways to animate things than just 14. There's things I haven't even gotten to yet, like WebGL. You can animate things with Flash, and there's also Marquee. There's all sorts of great ways to animate things, but I'm going to stick to these 14 for now. And it's useful to break these up into categories like browser APIs, animation tools, and other libraries. So we're going to use that as our organization today. We're going to start with vanilla JavaScript. Now, if you want to code something up, an animation in vanilla JavaScript, then I would recommend you look at Request Animation Frame. Request Animation Frame is a browser API. And all it does is it gives you a function. And it's called Request Animation Frame. And you pass in the name of your function into this function. And the way it works is you're telling the browser, hey, I have an animation that I want to run. And next time you repaint the screen, run my function to kick off my animation. So that's great. But that's not all. What people do with Request Animation Frame is When they define the function they want to pass in, they include request animation frame inside of that function as well. And then they call the name of the function they're passing in. So what you've set up here is you've set up a recursive loop, a loop that calls itself over and over again. And this is kind of like a poor man's event loop or a drawing loop like you might recognize from like game development or something like that. And inside of this loop, you put whatever you want to happen, right? And that whatever could be, moving a div on the screen or drawing a little bit of something on a canvas or changing a CSS property. It doesn't matter. As long as you do that little thing over and over again, it gives you kind of the underlying foundation that you can do to start moving and animating things. So that's how you do it, rolling your own with vanilla JavaScript. Another approach that you can use are CSS animations. There's 3 different buckets of CSS animations that I'm familiar with, at least, and those are using transitions, keyframe animations, and step animations. Transitions, the way it works is you get a class, and then you have a property on that class that you want to change. Like in this example, we have the opacity, right? We want to change the opacity from 0.4 to 1. And that change happens when you hover, right? When you hover over the box. Now, when we throw in the transition property, that says, hey, I'm going to add a timing element to this, right? So as soon as you hover, the opacity doesn't shift immediately. I want to put a 5-second, fade from this first opacity to the other opacity, right? So the machine, the computer says, okay, I'm going to bring you from one state to the other state, and I'm going to fill in all the states in between. And this works great for hovers. It also works great for some other limited use cases, like when media queries change or when you toggle a class on and off with JavaScript. Keyframe animations are a little bit different. With keyframe animations, you're kind of defining, it's almost like you're defining a function. You're defining a specific thing, and you're giving that thing a name. Like in this case, we define a thing called pulse. And what pulse is it says, okay, I want anything that has a pulse to go from opacity 0.4 to opacity 1, right? And then you can take that thing named pulse, and then you can put it onto an animation property in a different CSS rule. So what that does is it says, okay, this rule is going to adopt the behavior inside of pulse, and then we're going to make that happen over 5 seconds. And the thing that's a little bit different between this and transitions is you can start adding more properties to this animation object here. And you can add things like, I want this thing to pulse infinitely, or I want this to alternate directions, right? And there's all sorts of attributes that you can add on to this thing to make it pulse and behave how you want it to behave. So that's how you go about it doing keyframes. And the last one I talk about is step animations. Now, step animations are, it's a way to move between different images, right? So this is a sprite sheet, and if you're doing game development, and this might look familiar, oftentimes you get an image that has different positions of an object. And with CSS step animations, you can say, hey, I want to display the first image, then the next one, then the next one, then the next one in rapid succession, which gives you this appearance of motion. And the code to do that is pretty similar. You would use these keyframes, but down in your animation property, you say, hey, I'm going to say, I want this animation to happen over discrete steps instead of smoothly from the beginning state to the end state. And that way you can kind of iterate through these images. So these are some of the approaches you would do if you're using CSS animations. Now, there's another browser API called SMIL, or SMIL. It stands for something complicated, Synchronized Multimedia Integration Language, but I just think of it as animations inside of SVGs. SVG is a popular technology. It's growing really well. To animate them, you can use the animate tag, which is basically a markup element inside of an SVG, and you put attributes on that tag to tell it what you want it to do. Now, I mean, here's the tag right there. Now this seems really great, and you can do more than just the animate tag. There's a tag for transforms, and then there's a tag for motion, like animating across a curve or a path. And this is great. It seems like it would be really useful, except the problem is that it's actually deprecated. Many browsers started to implement this and then kind of backed off. The implementations you find out on the web are fairly inconsistent, and if you try to use this in Google Chrome, you'll get a deprecation warning in your console. And I think the reason for this deprecation is that a lot of browsers are starting to consolidate and focus on a newer API, which is called the Web Animations API. Now this is kind of the new hotness. This is what a lot of people are kind of looking forward to. And it looks something kind of like this. It's basically, you're writing web animations in JavaScript. You're defining your beginning and your ending states, and you're defining kind of the settings that you want to set on this animation, like the duration and the direction and those things. But then what you do is you grab a DOM element, like getElementById, and then you say, hey, there's a new method on this DOM element called animate, and I'm going to pass my settings into this animate function, or this animate method, and the box itself is just going to animate across the screen. So pretty handy. The only downside is the Web Animations API is still in working draft status with the W3C, and browser support is a little bit limited. You can look it up on caniuse.com. There is a polyfill that works pretty well, and that allows you to get this kind of API across all modern browsers. So if you want to explore the Web Animations API, I'd recommend looking that up. Now you can technically animate things with HTML5 video. It's not quite the same as some of these other approaches because it's embedded media, but you can use the video tag and you can do some things that you might not associate with video, like you can tell it to autoplay, or you can tell it to loop, or you can remove the controls or add your own controls. So this is certainly a way to animate things as well, and I do have an example, bouncing a ball with a video. And in that same vein, animated GIFs, it's a way to embed animations onto your web page, even if it's fairly old and has some drawbacks. And we're going to talk about some of those drawbacks in later slides. So let's look at some animation tools. These are JavaScript, third-party JavaScript libraries that are designed specifically for animation. Kind of the big one is GreenSock. And GreenSock is it's very popular, very performant animation library. And the code looks something like this. You basically grab an element from the page, and then you pass that element into a function, and you put all the settings in that function, and it takes care of the rest. It exposes a really clean API, and it's not just one tool, it's actually a suite of tools that you can use, kind of pick and choose which ones you want to use, which makes it fairly lightweight, and there's a big community of plugins. So there's not a lot to dislike about GreenSock as an animation library. It is a commercial product, so if you want to use it for commercial purposes, then you will need to purchase a business license. So that's a little bit of a downside, but you can use it for personal experimentation and learning free of charge. So that's GreenSock. Another one that's been around for a while is called Velocity. And Velocity was originally invented as an alternative to jQuery animations. And their pitch is that you can use the same API as jQuery animations, except Velocity can do it faster, right? So it's similar to jQuery. You're kind of chaining commands together, and you're telling this element, hey, I want you to change this CSS property, and then this CSS property, and take this much time. But honestly, jQuery has improved a lot in recent years, and since jQuery 3.0, they have a lot of the sped up performant approaches that Velocity was using kind of baked into it. So Velocity is good if you want to support older browsers and you want to have well-performing animations, but there's not much of a case to use it these days if you're on modern jQuery. There's a bunch of interesting open source animation libraries that have come out just in the last couple of years. Mo.js and Anime.js are two of the ones that kind of caught my attention. They both have, a lot of similarities. The APIs, you can tell, they look pretty similar. And their websites, there's a lot of really cool demos for these things. These are newcomer libraries, and I'm keeping my eye on them, just kind of see where they're going to go. Certainly worth checking out. We're going to start looking at these other category animation tools, and a lot of these are things that they're not expressly developed for animation, but they have some animation capabilities. jQuery is a perfect example of that, right? People usually don't download jQuery because it animates things, but if you already have it in your code base, it's a great thing to turn to for animation, right? And the API is similar to other jQuery use cases, right? You're chaining commands together and you're telling your element, hey, I want you to do these specific things. Another interesting project is called P5.js. P5 is based on a popular visualization language called processing. And for our purposes, what it does is it gives us a little bit of tooling around the HTML5 canvas that allows us to do animations on it. So one of these things it gives us is a setup function that allows us to create and instantiate our canvas. It gives us a draw function that we can use kind of like this draw loop that I mentioned earlier, and we can put things inside of this draw loop, and then it gives us a way to clear the canvas and all these conveniences where if you're working with canvases and you want to do animations, it can be pretty slick. I know Khan Academy uses this for their interactive JavaScript learning environments. So it's a pretty robust project and a lot to like about it. So there's also D3. Many of you have probably heard of D3. It's very popular in the data visualization world. It's good for working with data. Now, it has animation functionality built into it, right? So if you have an object, whether it's an SVG or an element on the page, you can chain commands onto that object telling it that you want it to do a certain kind of transition with a certain, kind of easing on it, and you can change individual properties of that thing, right? And this kind of makes sense, right? If you've ever seen a D3 visualization, a lot of them are fairly interactive, and there's animations going on there. So the last one I want to talk about is Matter.js. Now, Matter.js is fairly different than a lot of these other ones because it is a two-dimensional rigid body physics engine that's designed for the web. So this code, it's not saying, move my opacity or change my position. It's saying things like, oh, what's the friction or the mass or the inertia of an object, right? You're defining these physical properties on objects in a physical environment, and then you basically let it go and you let physics take care of the rest. So that's Matter.js. All right, we've kind of done a kind of whirlwind tour of all of these different ways to animate things. And you can compare and contrast, and there's a lot to be learned from each of these ways. As I was working on the Bouncy Ball project, I started to recognize some similarities between some of these. Some of these browser APIs and libraries, a lot of them use very similar approaches. And I started to realize that there are some animation paradigms that kind of surface as you're working through these kinds of animations. And when I say animation paradigms, I mean, if you take one of these approaches to animate something on a website, you're going to go down a very different path than if you take another one of these approaches. You can't just refactor from one of these approaches to the other, right? But a lot of times you might end up with the exact same result, same output. So I bounced a ball using all four of these approaches, and it looks the same when behind the scenes there's very different code and very different ways to get that same result. And each of these paradigms, they have strengths and weaknesses, specific use cases they work really well for, or cases that they don't work at all for. So let's talk about these. Math. My friend from junior high and high school. So with math, you can animate all sorts of things, and you can use mathematical functions in your animations if it answers this question. Can you represent the position of the thing that you're animating with a mathematical function, right? So this mathematical function that I have here on the screen, this is the function that I use to animate the bouncing ball. And if I were to graph this in like a graphing calculator or something like that, this is what it would look like, right? We have time on the x-axis, and we have height on the y-axis, right? So then as time goes, the height, it kind of peaks, and then it drops. And you get this repetitive thing happening over and over. And mathematical functions can be very convenient because they're very simple. It doesn't look simple, but this is one line of code, basically one line of code that defines the heart of your whole animation. And mathematical functions is like you put something in and you get something out. And this one line of code, you put in a timestamp and you get out a height. And there's an elegance to that I think is pretty impressive, right? Now, not every animation can be mapped out with a mathematical function, but for the ones that can, you can have very succinct code, and it can be really, really clear that way. This works, using math works really well for kind of lower level animations, like if you're writing something with vanilla JavaScript or maybe using P5 and Canvas, this can work really well. And I said position, but it's not just position. If you can represent the speed of something with a mathematical function, that could help. Or if you can represent the acceleration of something, that could also help. In fact, easing curves are nothing but mathematical functions that represent, speed and acceleration. So behind the scenes, math can do a lot for us. Now, you can also take a physics-based approach when you're animating things, right? And the best way to do this is to find a physics engine that does the work for you. So there's Matter.js, like I showed before, is a two-dimensional physics engine that works on the web, but there's also three-dimensional ones like Ammo.js and Canon.js. And in a physics-based approach, what you are doing is you're trying to replicate the real world inside of the browser, right? You're trying to create an environment, and you're defining, okay, what's the gravity in this environment? Or is there no gravity? Or is there gravity in the y direction, right? You're defining all of these things. What's the air resistance? What's the elasticity? You're defining physical properties that exist in the real world, and you're assigning them to the objects in this world. Once you've done all of that, you can kind of let the underlying rules of the physics engine carry the animations the rest of the way. And this is a really good setup for a lot of things. Let me give you an example. So this is an example from Matter.js, and it's a wrecking ball, right? So I can use this wrecking ball to knock over this tower of boxes. And I mean, obviously this is very physical. It looks kind of realistic how a real tower of boxes would work. But can you imagine how much work it would be to try and individually animate each one of these boxes, right? Maybe with vanilla JavaScript or keyframes. Like, you'd have to tell, like, okay, box on the left, I want you to shift 3 pixels and then rotate 12 pixels and then move down to the right. And then the next box above it needs to also do that, but kind of act a little bit differently because the wrecking ball is coming in this direction and there's probably a little bit of momentum. And you'd have to figure out all of these things. And it would be if you changed one box, nothing else would work. It would be a pain to maintain. It would be a pain to refactor. It would just be not workable. So if you have this kind of thing that you need to code up, you might want to look at a physics engine instead of trying to do it by scratch or do it with a keyframe animation. And you might have this kind of animation if you're doing game development, right? If you have a world where there's a lot of bad guys or there's a lot of, objects and they all obey the same laws, right? And you don't want to have to tell each one exactly what to do. You just want it to obey the same rules that exist in that environment. It also has a lot of good education approaches. When you're teaching about things that happen in the real world, you can demonstrate those things, on the web in this way. So another paradigm for animation is Flipbook. And many of you have probably used one of these as Flipbooks. It's just kind of a pad of paper, and you you kind of brush through the pages of individual images, and then it gives this appearance of motion as it's flipping through. And a lot of animation techniques, they actually use this like Flipbook approach. So a couple good examples of that is animated GIF. When you download an animated GIF from the internet, what you're actually doing is you're not downloading one image, you're downloading a giant stack of images, right? A whole Flipbook full of images. And then when you look at that on the browser, the browser is rapidly flipbooking through the Flipbook, right? And then as soon as you're done, it usually starts over again and goes through the Flipbook again and over again, right? It's a big Flipbook. And that's great. It looks good. It's very portable. It's nice. But it's also very heavy, right? Downloading images is costly from a time perspective and a bandwidth perspective. And if you're trying to download 500 images at once, it can take a ton of time. And that's why animated GIFs you see most of the time are very small, and they're really compressed, and they look terrible, because if they tried to make larger, uncompressed animated GIFs, then it would be just so large you wouldn't be able to download it, right? HTML5 video is an improvement on animated GIFs. It uses a lot of the same like Flipbook based approaches, but it has a lot of compression algorithms that are baked into it, right? So that only the data that's different from one image to the next is saved and stored. And so HTML5 video, you can save a lot of bandwidth by going that route instead of animated GIFs. And CSS Step Animations, right? I kind of mentioned this before with like the little Mario sprite, right? If you're flipping between individual background image positions, then you kind of get this appearance of motion, right? So when I talk about GIFs or video, the question kind of comes up, well, I know about GIFs, I know about videos, but should I ever actually animate things with GIFs and videos if I'm trying to add a little bit of like niceness to my user interface? Should I actually ever use a video or a GIF for that? Question is, the answer is that it's not, there's no cut and dried answer to that. In most cases, it doesn't make sense to use a GIF or a video. But there are strengths to GIFs and videos, especially the fact, with GIFs, they're super portable, right? So if you want to toss an animation over to someone, a GIF could make a lot of sense. A lot of chat applications make it so that you can send GIFs back and forth, and like that's not a bad thing, that's a good thing. So being able to support GIFs is a good thing. For video, there are a lot of video-like things that makes a lot of sense to animate things with. A really good example is I was looking at Google's material design documentation, and they had things that you should do and things that you should not do, right? And they decided to use video to animate these do and don't scenarios. And the way they did it was really nice. So video can make sense in those cases. Now, kind of one thing to watch out for, when I was implementing the bouncing ball with the video, I got it working, I turned off controls, I did all sorts of things. But then I realized that on some devices, especially iOS devices, they would stick a play button on top of my video. And that was something I was not expecting. It's certainly something that I didn't code in there. It turns out that, iOS did not like the fact that I was auto-playing video when someone landed on the page. So they wanted to make sure that the user could opt in. And that's a nice gesture, but like this isn't an ad, this isn't an annoying like autoplay type situation, right? It's not the kind of thing that I needed in my case. So this could, if you were trying to animate something with video, and this would be an anti-pattern, right? Like this could come back to bite you. Turns out you can work around some of these types of issues, but there's so many devices out there and so many types of browsers that inevitably you're going to run into a browser that is making some kind of assumption about what your video tag is for. So, I've found that it's best to use video to animate things that are video-like. Just things that, if this kind of case came up, it wouldn't throw somebody off terribly, right? So let's talk a little bit more about the CSS step animations. Again, this is another Flipbook style of animation. This is the sprite sheet that Twitter uses to animate when you like or favorite something, right? It starts out with like an empty heart, and then there's all these individual circles and shapes and particles and things, and you end up with a filled heart, right? And they chose to use CSS Step Animations for this animation. And when they shift the background position rapidly between all of these positions, this is what the result looks like. It looks pretty good. The thing that I like about this is, you could have done this with CSS keyframes. You could have done this with something like GreenSock, but it's a really good fit for CSS animations. And the reason why is there are lots of like little bursts and particles that are coming off of this heart as you favorite it. And if you were to do this animation with CSS or with something like GreenSock, each of those particles would probably be another element in the DOM, right? It would be a div or a span or something like that, or maybe a little element inside of an SVG. And when you have a lot of little particles going in very specific directions, like giving instructions to all of those can start to get kind of heavy, and moving, repainting these particles across your browser can, it could be kind of heavy. It could get a little bit laggy, right? But when you're doing it with the step animation, all of those particles have been pre-drawn into this like graphic, right? So the browser doesn't care about anything. All it knows is just shift the background position of this image, 30 times in a row, and that's all I have to do. So this can be a really performant solution. It works, really well for little bits of user interface, and if you're trying to add just a little bit of spice in small areas to your user interface, CSS Step Animations can be a great option for that. Now, this other paradigm is something that goes by the name of tweening or possibly keyframes, right? Both of those names are used in different places. Tweening comes from the word between, right? And the way it works is you define a beginning state and you define an end state. So it's like saying I have a box and the beginning state is red or the end state is blue. And you say, this is all that I care about. I am only going to define the beginning state and the end state, and I'm going to let the computer figure out all of the states in between. And I'm going to let the computer transition me smoothly from the beginning state to the end state. Any animation library that does that is using this tweening or this keyframe-based approach. And color is one thing that you can tween, but it's not just for color. Like you can do it for width and height and opacity and basically any CSS property that has a number on it. You can go between those different values. And if you were to look at these 14 ways that I talked about, most of them use this kind of approach to animation, right? So here's an example from the CSS animation, right? You have a from and you have a to, and you're saying, okay, I'm defining discretely what from is and what to is, and I'm going to let the computer go between them. And it's pretty cool. So the problem I have with tweening is like, okay, I get that I can change a color, but when I want to do something like this, right, this animation that I started with, how do I get from shifting a color to something as complex as this? And I think this was like kind of where my sticking point when I was trying to learn a lot of these things. There's something I realized, I had a realization when I was, again, looking at Google's material design animation guidelines. And this is the example that they gave. They have a little kind of a little card, and they want to animate this card to expanding. And this is not super complex, but it's a lot more complex than some of the other examples we've looked at. So what we have on the left side is the animation, and on the right side we're seeing all of the properties that are changing and at what time they are changing, right? So for every single one of these properties, you're defining a beginning state and an end state. A lot of times it's a position or an opacity level, right? And we're just changing them all at the same time. We're changing width and height and X position and Y position and opacity, right? And what we're doing is we're basically taking, these individual aspects of this animation and we're composing them all together. So we're keyframing, 6 different things. And when you bring those all together, you get a holistic animation that kind of moves smoothly in unison. And this was kind of an aha moment for me because I realized, oh, you can take a complex animation and you can decompose it into the individual things that are changing, the very small bits. And if you do a keyframe, if you tween between the beginning and ending state of each of those bits and bring them all together, you can make fairly complex things. It's all about decomposition and then composing things back together again. So I think that's why so many libraries are using keyframes. It's because it's kind of the building blocks of doing even very simple animations to very complex ones. Now, I want to talk a little bit about animation performance. This is a question that came up a lot in the GitHub repo for this project. A lot of people would say, oh, you've done all these animation techniques. Okay, which one is the most performant one? Which one's the fastest one? And the answer is there's no silver bullet. There is no fastest one. And I wanted to kind of explain this with a story. So last year, I attended a conference called Converge Conference. And there was an event there called CodePen Show and Tell, where people would kind of make a CodePen, and then they'd come and show a group what they had built. And a lot of these were kind of visual, and there were a lot of animations. And I wanted to do a CodePen Show and Tell. So I put together something that looks like this. It was a Conway's Game of Life visualization. So they're these kind of pixelated looking things that move around on this plane. And I thought it would be pretty cool. I wanted it to be super fast, so I decided, okay, I'm going to go with CSS animations. People often say CSS animations are the most performant option, and certainly in many cases there are. So I used a library called voxel.css, and I made CSS animations for all of these, and I was pretty stoked by it. I found that there were actually it was pretty laggy in some cases, so I worked on some optimizations. I tried to improve it a bunch, and after all my optimizations, I took it to the CodePen Show and Tell, and I started showing people, and a lot of people liked it, and I was feeling pretty good about it. But someone in the crowd said, hey, it looks like this is a fairly small grid. Can you make the grid bigger? And I said, I guess I could. And I mean, the variable for the grid size was right there on the screen, so I couldn't just say no. So I changed it from 16, which is 16 by 16 grid, up to something like 30. And I hit the play button and kind of crossed my fingers, and we were waiting and waiting, and nothing was happening. And then it started looking really wireframey, and the colors were off, and it was just kind of crashing and burning right there on the stage in front of everybody. And it was embarrassing. It was embarrassing. I thought I had done the right thing by using CSS animations. It turns out every single one of these pixels is 20 HTML elements. And when you go up to 30 by 30, you're talking over like 35,000 HTML elements on the screen. And when you're trying to make one change to a DOM that has over 35,000 nodes in it, the render tree just collapses, and it makes it really, really tough to animate things. So there's no silver bullet to animation. If you want to know how to make your animation performance better, then what you need to do is study rendering performance. And rendering performance is a different type of performance than a lot of us as web developers are familiar with, because we're really good at reducing HTTP requests, compressing images, making download speeds really, really fast. But rendering performance is an entirely different way to optimize a website. So there's a lot of good resources on how to get good at rendering performance and how to debug rendering issues. I would recommend jankfree.org, which itself is a collection of resources for this kind of thing, and there's also a really great Udacity course on it. But if you have animations that are not performant, rendering performance is the thing you need to learn in order to improve it. Now, the closest thing that there is to a silver bullet is this. And basically, if you were to take away one performance tip away from this talk, it would be to only change these 4 things when you are changing a property of an HTML element. Because these are the things that a browser can animate cheaply. It's position, it's scale, rotation, and opacity. And the reason these things are cheap is because they don't change the flow of the document and require the browser to recalculate the position of everything on the page. So this is a good place to start on a performant application. And these are really good, especially for CSS animations. But you can get into a lot more detail when you really study rendering performance. So that's all I really have to talk about. I hope that you learned something interesting. Any questions about animations? Yes?
Sorry, for the recording, could you come up here, please?
So for Edge Animate, it was a visual tool that produced horrible output.
Yes.
But it provided a creative way of developing the animation where the client could hand you the animation straight without having to program it.
Yes.
Did you research any tools that created a visual way to create the animation and deliver decent output?
That's a good question. There are a lot of new tools that have come out just in the last couple of years. One is called Framer. I know that one's fairly popular. I haven't ever seen one that makes output that I would put on a production website. But it's certainly, I mean, I don't want to like diss on Edge Animate. Like it certainly served the purpose of communicating that animation from the client to me. So it's a useful tool in that regard, but I haven't found anything that produces, really solid animation code.
And then the second question is, did you find a disparity between what the client gave you in terms of their visual production and your recreation of it in a, I assume, keyframe framework?
Yeah, so the sad answer to that question is that we ended up not reproducing it fully. It was, there was an argument to be made for including it, so it just kind of ended up getting included on the website for a short-term project. But I imagine that, if I wanted to, right, knowing what I know now, I could probably reproduce, exactly, or fairly exactly the same visual output that they originally wanted,
Okay, thanks.
Yep. Any other questions?
All right, everybody, let's give another round of applause, and I'll see you at the exhibit hall.